Okay, in this section, we're going to do 1.3 solving for a variable. Sorry about that. We're going to solve for a variable. And if you understand the concept of what we are doing and the idea behind it, once again, we're trying to make it easier for you to understand what's going on. So I want you to think about a scale. And this scale gets broken up in math with an equal sign. Okay? So when we break up this scale, imagine you're putting an equal sign right here in the center. And we want it to balance out. We don't want one side to be heavier than the other. We want to balance it out. So we want them to be the same weight, the same type of weight on both sides so that it balances out. Okay? So when I show you these two stars, when we put 20 on one side, we want to put 20 on the other side so that we balance it out. And if I were to legitimately take this 20 off of this side, then it would go whoop, and the 20 would just throw the scale way off. So then we would have to take the 20 off this, okay? So that we rebalance the scale. So when we do these types of things, there's names mathematically for what we call them. However, for today, we just want you to understand you're trying to balance this idea. So what happens if I put 20 on here? We're going to go whoop, and that scale is going to be way off kilter. And now let's throw another one on. So now we have two 20s. That scale is going to be really still sitting way, well, I guess it would be way here because all that weight would make it pull to the ground, and then the other side would be way up here. So what do we need to do? Well, we've got to come up with some ideas to balance off the side so that we go, okay, now we're back to even playing field. That's what solving for a variable is doing in a mathematical sense. We're balancing the scale. Okay, so when we look at these problems, that's ultimately all we're trying to do is figure out what weight needs to go on the other side in order to balance out our scale. And when you think about some of these, like if I even look at this one to start off with, and we're going to start right here. X plus 6. So I'm going to take something. I want to add 6 to it. But remember, on the opposite side is 19. On 19 on this side. So if I already have 6 over here, how many more am I adding to it? What's that box? What's the weight of that box got to be in order to balance it out so that we're not one way or the other? So we have a process to do this. And you're probably already telling me that it's 13. It's 13. Schmidt, it's 13. You know it's 13. Great. I'm glad you know that. But let's show the mathematical steps in order to get that answer. So what we're going to do first, in every single one of these problems, we want to highlight our variable. Wherever our variable is, we want to highlight it. Okay? Then with a different color, I'm going to draw a line down the middle of my equal sign. The reason I'm going to do this is so that I know what sides of the scale I need to balance. Remember, there's a balance, and when we talked about that in the scale sense, what did I put in between them? I put this equal sign in between them so we can balance out one side versus the other. You have to know where the division is between our two sides of our scale. It's very important for us, especially when we're going to try and solve these, because what we're going to do is what they call an inverse operation, which is just doing the opposite mathematical operation. So when we look at inverses, the inverse to addition is going to be subtraction. The inverse to multiplication, I guess I don't like that symbol. Let's do this. let's do the double arrows. So arrow this way, arrow that way, double arrows. So multiplication we're going to say is division. If we have an exponent, we do a square root. And we won't get into those today, but just so you have an idea, and there's a lot, oh, it's even hidden from where I put it. And there's going to be a lot of those that we aren't really going to talk a whole lot about today, but we will later on. Oh, man, now I'm getting, oh, bummer. Let's do this. Never mind. Let's go this way. So I did x to the number, and then we're going to do this and put the number here and put the root there. So whatever the exponent is, to get rid of it, we're going to square root it by that same number. Now, we won't focus on that today, but that could be something in your future that you'll want to take care of. But that probably won't be towards the latter end of Algebra 1. All right, so our inverse operations, we're doing the opposite mathematical operation. So addition, subtraction, those are inverse operations. Multiplication and division, those are inverse operations. So when we look at this, we have an x plus 6, and then our equal sign, and then our 19. Okay, so what we want to do is focus on the highlight. Where is our highlight? And you're going to say, well, the highlight's right here. Well, what numbers are on the same side of that highlight? What do you mean by that? Well, there, remember, we broke it up. We broke up the equal sign with that highlight. So what numbers are on the same side as our variable? And now you're going to go, oh, well, I know there's a plus 6 right here. Okay, now what's the inverse operation of a plus 6? Well, it's going to be minus 6, okay? But remember, we're doing a balancing act. There's a scale here. If you start taking something off from one side of the scale, what do you better do to the other side? You better take it off of the other side of the scale. And we call this a property of equality. Property of equality. We're going to do something that's the same on both sides of our equation. And remember, it's an equation because it has an equal sign. If it doesn't have an equal sign, what was our vocabulary term for that? Yes, an expression. Yeah, remember that. That was our first section we talked about, the expressions, combining like terms, that kind of stuff. So, property of equality. Now, in this problem, we did something to both sides. What did we do? Subtraction, Schmidt. So then it becomes a subtraction property of equality. Because we're doing that same operation to both sides, it becomes that operation's property of equality. So in this sense, what happens to a plus 6 and a minus 6? I need to just, oh, sweet. It worked, actually. I want to combine the plus 6 and the minus 6. So if I have 6, take away 6, you're probably, hopefully saying in your brain, well, that's 0. Good. You should say it's 0. However, what's still there? Now, you could do x plus 0, but I would challenge you to avoid that. Understand you know it's 0, but we still have to bring down what we have. So we still have an x here. And we're going to put it equals on the highlight because that's for our equation. And then we're going to do 19 take away 6, and we're going to get, voila, our 13 we talked about at the beginning of this problem. But these are the steps that you want to go through in order to get that. So let's talk about A. Well, we did the underline and draw the line. So we underline our variable, draw the line down the middle, equal sign. Look at the side that has our variable. We need to get rid of a number, and we need to get rid of minus 11. So the inverse operation, doing the opposite mathematical operation of subtraction, is going to be addition. Because what happens if we have a negative 11 plus a positive 11? That's going to zero out. And we could even put here, we zero out the 6's. So we did the subtraction property of equality, and we zeroed out the 6's. Well, this one, we're going to do the addition property of equality. And remember, I want to give you your agency for your education. I want you to understand why you're doing something, because if you understand why you do it, it's much easier to do it. You understand that I need to add something to both sides to get rid of this number. I want to zero out the 11s. That's why I'm doing the addition property, because when I zero out the 11s, all I'm left with is x and whatever x equals. So now I have that ownership of, I know why I want to add 11, because I want to get rid of the negative 11 that is over here in order to get x by itself, because x equaling something now tells me what that unknown was. Remember, our letter just stands for the vocabulary term for variable, and a variable just means something we don't know the value to yet. Okay, but once we do this, we will understand what the value is, and that value is going to be -4. Because if you give me $4 and then you give me 11 more, that means you are out $15 or -15. All right, next one. We need to understand the operation that's between -3 and x. So I'm going to rewrite this. I'm going to rewrite -3. I'm going to put a space in between here. X equals 48. So what is in between the -3 and x? Well, think about what you do when you have 2x. And what happens when you put a 5 in there? What are we doing to that? Aren't we doing multiplication? So even though there's no operation that is shown there, remember we could put a dot, and that stands for multiplication. So when we go back to our inverse operations, doing the opposite mathematical operation, if I have multiplication, what do I need? Well, that means I need to divide. And I'm going to bring him back red, and we're going to do the division property of equality. So we're going to do something to both sides. Now we're going to divide. What happens when we do division? What happens when we divide a number by itself? Please be careful. Slow down. Think about it for a second. Because you're going to want to say, well, we zero it out. Do we though? Does the x disappear? No, we don't want the x to disappear. We want to figure out what the x equals. So what are we doing? Well, anytime you divide a number by itself, we are going to get a 1. We are 1ing out the 3's. Okay, so when we do that, there is a process that happens here, and we do 3 divided by 3. We are going to get a 1. And we're going to talk about that in a second. However, what is on top that we haven't dealt with yet, that we need to deal with? Yes, the negative. So we actually need to divide this by a -3. So because we want to get a 1 by itself, not a -1. -1, we still got work to do. But if we get a +1, we're good. And we can sort of stop there. We'll talk about that in a second. But we want to get 1x. We want to get 1x by itself, and then we can be done once we do a very simple step. So then we're going to do 48 divided by -3. And if you haven't done long division in a minute, once again, I want to give you the fundamentals. So let's do that. And we're going to take 3, and you can put the negative here. The negative is just going to go in front. We could do a negative times a negative. a negative times a positive times a negative, and a positive times a positive. Well, 2 times 2, that just gives me a positive answer. A negative times a negative gives me a positive answer. And so what you can do with this sign chart, this is the sign chart, is you could replace all of these multiplies with divides. So if you only have one negative when you're doing that, it's going to be a negative answer. Whether it's the first one, whether it's the second one, whether you're multiplying or dividing, doesn't matter. If you only have one, it's going to be negative. But if you have two, a negative and a negative, make it what? A positive. Remember, we wanted a positive one here, so that's why we have to have two negatives there. Okay, so how many times does 3 go into 4? Well, we can take one of them because 1 times 3 is 3, and we subtract, we get a remainder of 1. Bring down the 8, and then 3 goes into 18. You got it, 6 times, because 3 times 6 is 18. So this is going to become negative 16. Now, you don't have to believe me. Let's do 48 divided by divided by negative 3. And what do we get? Negative 16. Always trust what the machine will tell you, because the machine has no bias. It's not going to make mistakes unless I input the mistake myself. All right, so we got to 1x equals negative 16. And you could go through this whole idea and process of, well, let's divide it by 1, I would tell you to hold off. Don't go too fast. Okay, apparently I'm just going to have to rewrite it. Okay, so we have 1x. And what I'm going to ask you is, what am I holding in my hand? And it's a special pen, but it's just a pen. Okay? And hopefully you said I'm holding a pen in my hand. Now, think about this. How many pens am I holding? Holding one. But when I asked you, what am I holding? Your brain probably just said, a pen. Did it say one pen? No, because in the English language, we don't say, I am holding one pen in my hand. A pen makes it singular. Well, the same thing happens in math. You don't have to say, I have one X. By claiming that it's an X, we know there's only one of them. That is the singular connotation for it. So whether you want to talk about holding one pen in your hand or just saying I'm holding a pen, I'm holding a X. I don't need to write the one in front of it because I know it is singular. Okay? So anytime you see that one there, try to train your brain to negate it and just, I already know it's singular. I do not need the one there to tell me that. So your final answer is negative 16. But how the one disappears, it doesn't really disappear. It's just proper English and proper mathematical speak. We don't want to write the one there because it doesn't, it's kind of redundant. Okay? All right, last one. In this one, let's rewrite it instead of x over 5, because I'm sure that's how you're reading it. Start to train your brain to read x divided by 5. Even though it's you have trained yourself, well, it's x over 5. But x divided by 5, I can start to use inverse operations, because what's the opposite of divide? Multiply. What's the opposite of over? Under? Like, that doesn't make sense for me, my brain. When I'm trying to do math, under and over don't really comprehend for me. But if I were to read it as x divided by 5, now I can flip that inverse operation idea and do multiplication and multiply both sides by 5. And you can put the x there. I try and put a big fat dot to represent multiplication just so that we don't get the x and multiply confused. Now, we did multiplication, and we are doing the property of equality. Okay? And when we do that, what is going to happen to our 5s? Well, a 5 below and a 5 above, 5 divided by 5, we go back to that one idea. We are wanting out the 5s. And we're going to drop our equal sign down on our highlight, and then we just do negative 12 times 5, and we're going to get negative 60. So I don't know where you're at, how you feel about these, but this is solving for a variable in a nutshell. Balance that, both sides, the right and the left, and figure out what's going to work. If I take a negative 60 and I divide it by 5, am I going to end up with negative 12? That's all we're trying to do. We're trying to balance out this scale. And if I were to do negative 60 divided by 5, and I should come up with negative 12. I want to balance both of those sides out. Okay? All right, so let's challenge ourselves. Let's step our game up and see what we can do with these. Now, same process, but you got to remember it. Underline the variable, and then draw a line down the middle of the equal sign. Okay? Now, this is where we play the game of what numbers are on this side. I'm going to fix that just a little bit because I was badly drawn, and I want it to really kind of go straight up and down. All right. So when I read this and how you read this, it is going to be different. It is. But if you start to mathematically train your brain, I'm going to read 3x minus 2. 3x minus 2. And then you can write equals 58. I'm not worried about the other side because the other side's going to handle itself. I need to get the variable, the x, by itself. I need to get that variable, that unknown, by itself. So I really want to isolate that. But I've got two numbers here. I don't know where to start. So that's where we got to start reading it. And how we read it is 3x minus 2. So what's the one that's farthest away from your x? Is it 3x minus 2? Well, if we think about it, then that minus 2 is the last thing that gets said. So that tells me that that's the first thing I want to get rid of. So how do I get rid of a minus 2? What are my inverse operations? Remember, if we have subtraction, we use addition. If we have addition, we use subtraction. So if I have a minus 2, I want to add 2 to both sides. And I call this addition prop of equal. Because we want to do the addition property of equality. Now, addition property of equality, writing it out every time gets very lengthy. It's not a bad thing to do, especially when you're first starting. But once you get that mathematical brain taught, you can do add prop of equal. And that will tell you addition property of equality. But until you can tell me that this is addition property of equality, I would write out addition property of equality every single time. Please. This is what's going to make you a great math student, not me. I don't want to say I'm a great math student, but I know what these things stand for already. So until you can tell me what all these things stand for, please write it all out. Addition property of equality. Because I will say addition property of equality, and you've got to go, oh yeah, it's right here. I see it. Okay? And when we do the addition property equality, what happens to our plus 2 and our minus 2? We zero out those 2's. So understanding why you're doing something is the most important thing in your math career. All right, so these zero out. I'm still left with a 3x. And then I have 58 plus 2, which will get me to 60. Okay, so I have 3x Well, let's backtrack a little bit. Didn't we have something similar? Oh, yeah, we had negative 3x. Well, what was in between that 3 and that x that we talked about? Oh, it was multiplication. So there's multiplication in between these two? Hopefully your brain can start to get there. If it's not there yet, that's okay. I promise you. This is the first time you might be going through this ever in your life. So don't please pay attention to details. Go back, review it, watch it again and again and again. Do yourself whatever favors you need to for you to become successful. Remember, this is all about you. Anything I do in my classroom, I will tell you, is for my students and my students only. It's not for me. It's for my students because I want to make them the best they can be. All right? So you do whatever's going to make the best for you. So we have a 3 times x. So how do we get rid of multiplication? What's the inverse operation? Then we're going to bring in division, property of equality. So we are going to divide both sides by 3. Now, when you do this, you can write out the divide sign. More oftentimes than next, I want to get people ready for college. And in college, you are not going to see divided by 3. You're going to see a division or a fraction bar and then put the 3 below it because that stands for the same thing. So stop thinking over x over 3, 60 over 3. Start saying 3x divided by 3. If you can start to train your brain to say that, then you can start to use these lines and they make sense to you. So what happens to the 3 divided by 3? We talked about that. We are doing what? We want to 1 out the 3's because once we 1 them out, we've got our variable by itself. And then we can do 60 divided by 3. Well, 3 times something gives me 60. 3 times 2 gives me 6. 3 times 20 gives me 60. And there you have it. And these are the steps that you want to take to solve all of these types of problems, no matter how tricky they get. Now, you can already see, oh, there's a fraction in here. That's going to throw me. No, don't let it. Don't trust yourself in what you're doing. Okay? And if you have this machine, let it do the work for you and trust that you will finish it. Okay? So let's look at this one. I'm going to draw my line down the middle of the equal sign, or my pen's going to disappear while trying to do so. So here's my equal sign, and we're going to underline our variable right here. Here's x. So I have 1/2 x plus 4. Remember, you're saying it to yourself. Slow it down. So how do we get rid of a plus 4? We minus 4. And that's sub prop of equal subtraction property of equality. Why are we doing that? Because we want to 0 out the 4's. Because what happens with a plus 4 and a minus 4? They cancel each other out, and I'm left with 1/2 times x. Ooh, but 1/2 times x, Schmidt, I don't do Relax, it's okay, we'll get there. And then we do 10, take away 4, and we got 6. Now, remember, what are we trying to do with this idea of our number in front of our variable? Remember, we want to 1 it out. So if we rewrite it, can we rewrite it as x over 2? Because if we multiply this, we can put a 1 underneath. 1 times x is x. 2 times 1 is 2. So we're rewriting this as x divided by 2 equals 6. And then, and you could put simplify. I use simplify a lot, or rewrite the formula however you want to dictate to yourself that you did it this way. That's how you want to do your process. So how do we get rid of divide by 2? We want to do our inverse operation of multiplication. So I'm going to do times it by 2. So this is going to be mult prop of equal. So the multiplication property of equality. So we could do 2 times and 2 times. And then I could kind of shift these off over here. Okay. And when we multiply both sides by 2, this is going to one out our 2's so that we're left with x equals, and we should get 12. And that's going to balance our scale out on both sides. Hey, babe. Did you need something, or are you just?
Chair's down. Just leaving.
Okay.
Although I should have thought about it because Dom came over and him and Sullivan were yelling and talking the whole time right on the porch. So he didn't focus at all. So I should have had them move.
All right. So we have x divided by 5 minus 2 and then equals the other side. So when we look at this, x divided by 5 minus 2, your brain is already starting to train itself. And we're going to do add prop of equal. And we're going to get x divided by 5 equals -2. So x divided by 5, your brain's already telling you, multiply by 5. And you're going to get x equals -10. Now, we didn't write everything out, so go back and see if you can fill it in. Well, we did the addition property of equality. That got us to x divided by 5 equals -2. But how did we get there? We zero out the 2's. And then what did we do? Mult prop of equal, because we multiplied both sides by 5. And then what happens when we multiply by 5, divide by 5? We one out the 5's. We get the 5 by itself. It's almost like 5 divided by 5. Those one each other out. So if we wanted to rewrite it like this, as opposed to just that dot 5, we could do this times 5. And that's where the -10 comes from. The only reason I did it down here is so that we could write that justification. So when we do times 5, that justification doesn't get lost in the shuffle, which is what I don't want to have happen. All right. If we feel comfortable, we've got some challenges coming up. So, don't change what we do. Draw a line down the middle of the equal sign. This might be a little trickier, but I'm going to try and highlight that variable. And we have 2 times x minus 8 divided by 3. So there's a lot of things going on. We have 2x minus 8 divided by 3. What's the last thing you said? Is divide by 3. In these cases, and you can read, get rid of the denominator first. But you can understand why. When we read it, it's the farthest thing away, because we have the quantity of 2x minus 8, and that whole thing is divided by 3. So it's the number that's farthest away. And you could even think about it as 2x minus 8, that whole thing is being divided by 3. That's so far away from the problem, so far away from the variable, because we have 2x minus 8, and then all of that gets divided by 3. So it's the farthest thing away. Well, that's the only, so we know that that's where we want to start. How do you get rid of a divide by 3? We times by 3. Because that's the multiplication property of equality. So if we do that, what happens to the 3 down below and the 3 up top? Well, they one out the 3's, and I'm left with 2x minus 8 equals, and then this is going to be 60 when I do 3 times 20. All right, so now I still want to highlight my variable, and my equal sign I could make even longer. So now I've got 2x minus 8. So start to mathematically train your brain to go, okay, well, I need to get rid of the minus 8. So the opposite of subtraction is addition. Keep the number the same, and I'm going to do the add prop of equal. So that's going to leave me with 2x equals 68. And we zero out the 8's. And then your last step, 2 times x, we want to divide. Division, div prop of equal, division property of equality. We're going to divide both sides by 2 so that we 1 out the 2's. Okay, so the 2's are going to cancel, and I hate to say cancel, but we're going to 1 out the 2's, and we're going to be left with x equals, and we're going to be left with 34. Okay, so balancing this scale out, if we were to put 34 in for our variable, times it by 2, subtract 8, divided by 3, we should get 20 as our final solution because they should be balanced. Yeah.
I don't know what I'm doing out there.
Okay. All right. I'm going to give you D to do on your own. Multi-steps. So there are multiple steps that happen in these types of problems. What we want to do first here is combine like terms because we have a flower here and a flower there. So before we do anything, let's do 4x, take away 2x, combine those two flowers. Remember, use the coefficients. We're going to do 4, take away 2, and whatever that comes out to be, that's going to be the number next to x plus 1 equals 9. Now it's set up just like we have been. So the first thing we're going to do is this and say combine like terms. Now you can underline, draw your line, solve it out. For this type of problem, for the next one, we need to distribute. So we're going to do distribute or distributive property. Distribute property. And we're going to do 5 times x to get 5x. And then 5 times 3 to get 15. Keep the sign in between them, equals 10. And once again, it's set up, already ready for you to go. Underline, draw your line, underline, draw your line, and go through those same steps. Okay? Don't get hung up. And if you need reminders, here's a list we have right there for you. Okay? Ooh. Now, these I am going to talk about. When we underline our variables, so you're going to underline, underline. And then we're going to draw a line down the middle of the equal sign. What do you notice about our highlights? And I'm actually going to go back to this problem before. What do you notice about our highlights for this problem? Are they on the same side? Are they on the same side, or are they on opposite sides of our highlight? And you can see the two greens are on the same side. That's what indicated to me to combine like terms. So if the highlights are on the same side, we combine like terms. if they are on opposite sides, what we want to do is we want to throw all the x's on one side or the other and throw all the numbers on the other side. So you can, it's as long as you do good math, you can do it either way. So I can subtract 9x from both sides, or I could subtract 17x from both sides. But whichever way you do it, I don't want to deal with negatives, which is why I'm going to do 17 take away 9 as opposed to 9 take away 17. Because I could have subtracted 17 from both sides, but that would have left me with a negative answer on this side. And if you don't know what I'm talking about, think about it this way. If I subtract 17x on here and here, what's 9 take away 17? Isn't that a negative 8x? Yuck. Not something I want to deal with. So what I'm going to do is I'm going to underline, draw my line so I see the highlights are on opposite sides, and I'm going to just take the smaller number. Definitely if you have a negative number, just add it to the other side, but if I have a smaller number, that's the one I'm going to subtract from both sides. And when I do that, 9x and the negative 9x are going to, so this is a what? Subtraction property of equality. Yeah, but Schmidt, there's a variable next to it. You're still subtracting on both sides, aren't you? So the fact that there's a variable with it doesn't even matter. Keep doing what you've been doing. Keep doing what your algebra brain wants you to do. So when we do that, we are zeroing out the 9s. What? Okay, well, I will wrap it up. So the 9s are going to cancel each other out, 0 out, and I'm going to do 17 take away 9, and that's going to leave me with 8x plus 9 equals 17. Once again, set up exactly the way I want. Now for this last one, I'm going to distribute. Once I distribute, I've got a 3x plus 9 equals 2 plus 4x. When I highlight and draw my line, what do I notice about my highlights? They're on opposite sides. So do I want to subtract 4x from both sides or subtract 3x from both sides? Hopefully, you're going to start to train your brain. And remember, this is subtraction property of equality. We have 9 equals 2, and then we're going to do 4x, take away 3x, which is just going to leave us with 1x, which we know is just a plain old x. All right? And now it's set up, once again, underline. Now we just got to subtract 2 from both sides, and we're done. Okay? So keep practicing. Once again, ask questions. Ask as many questions as humanly possible, whether it's your teacher, come see me, get help from wherever. We want you to be successful. We want you to learn. We want you to be comfortable with your mathematical thought. Okay? So until next time, have a blessed day. Don't forget, join the Discord, join my TikTok, all those good things.